Today's lesson is 7.6, Solving Exponential and Logarithmic Equations. To solve exponential equations and logarithmic equations, we're going to be using the inverse properties. So, the first thing you need to know is that e to the x is the inverse of ln x. So we're going to use e to the x to get rid of ln, and we're going to use ln to the x to get rid of e to the x. Another thing that's good to know is that ln x, being the natural log, actually means log base e of x. I think this came up in 7.4, but it's a good thing for you to remember. So since we're going to use e to inverse log and n to inverse e, we have lots of examples to go through. So let's try one. If I have e to the x equals 1, I need to get rid of e so that I can get x by itself. To get rid of e, I'm going to do ln on both sides of the equation. ln of e to the x equals ln of 1. Now because ln and e are inverses of each other, x is all that's left. So x equals ln 1. And you can use your calculator to solve this, but ln of 1 is just 0. So this equation, x equals 0. However, if I have 5 to the x equals 12, this is not e, and this is not ln. So we have to use a logarithm, because logarithms are the inverses of exponentials. Since this is base 5, we're going to do log base 5 of 5 to the x equals log base 5 of 12. This part, the 5 to the x and the 12, that's what we had to begin with, and the log base 5 that we put on both sides is what we're using to get rid of it. Now log base 5 of 5, those cancel each other and leave x. And on the right side we have log base 5 of 12. Now, how do you put this into your calculator? We have a special formula called the change of base formula. You don't need to know that, but that's what I'm using. You rewrite log base 5 of 12 as log 12 divided by log 5. Log 12 divided by log 5 can go into your calculator exactly like that, log 12 divided by log 5. Remember that if you're using the TI-73 to find the log button, you press math and cursor over to log. Once you plug this in, you get 1.543. And we're going to round it to 3 decimals. And that's your answer. We're going to have a lot of decimal answers for these problems. The next problem is 3 to the 4x equals 27. So my base number is 3, so I'm going to do log base 3 of 3 to the 4x equals log base 3 of 27. Log base 3 of 3, they cancel each other out and just leave me with 4x. See the 4x? And log base 3 of 27 we're going to rewrite as log 27 divided by log 3. So 4x equals, I'm going to put log 27 divided by log 3 into the calculator, and it turns out to just be 3. So divide both sides by 4, and your solution, x equals 3 over 4. Just like that. Alright, let's try this one. 4e to the 3x power. We equals 1. We have a little bit of a problem here because we have a 4 now. Remember, this 4 is a coefficient. So to get rid of e, we have to use ln, but we can't have anything in front of the e. So the very first thing I have to do is divide both sides by 4 so that e is the only thing on the left side of my equation. Now I can use the inverse, which is ln. So I'm going to use ln of e to the 3x equals ln of 1 over 4. ln cancels with e, and we have 3x equals ln of 1 over 4. Divide both sides by 3, and x is ln of 1/4 divided by 3. So we're going to put that all together in my calculator. I'm going to do ln of 1/4 with parentheses around the 1/4 divided by 3, and we're going to get negative 0.462 for x. Okay, for this next example, again, we need to have the base and exponent part by itself. So I have to get rid of this -4 first. So I'm going to add 4 to both sides, which gives me 7 to the 2x minus 3 equals 18. Excuse me, I have to erase that for a minute. Didn't write it very well. So now that 7 to the 2x minus 3 is the only thing on the left side, I'm going to use log base 7 because I'm dealing with a base 7. So on both sides I have log base 7. And log base 7 gets rid of the 7. So I have 2x minus 3 equals log base 7 of 18, which we are going to rewrite as log 18 divided by log 7. Now I'm going to go ahead and put this part into the calculator. So I have 2x minus 3 equals 1.485 because that's what I get out of my calculator. Now I need to finish solving this to get x by itself, so I'm going to add 3 to both sides. So 2x equals 4.485, and I'm going to divide by 2 on both sides. So x equals 2.242 for my solution. Alright, that's how we solve exponential equations. We use a logarithm to get rid of it. Now we're going to solve some logarithm problems, and so we're just going to use the inverse, which are the exponentials. So for some of these we're going to be doing some rewriting. Now the first thing you need to know for this first example, we have log x equals 3. Anytime there's not a base listed here, the base number is 10, because our number system is based on base 10. So anytime the base 10 comes up, it's assumed to be understood by everybody, so they just don't put it on there. So I'm going to rewrite this first as log base 10 of x equals 3. Then I'm going to rewrite this whole problem as 10 to the third power equals x. And then I'm going to write 10 to the third, which is 1,000, equals x. And that's my solution. That's how we're going to work a problem if we have a logarithm on one side equal to a constant on the other side. For the next example, I have ln x equals 4. So we could rewrite this as log base e of x equals 4, because as I told you at the beginning of this video, ln x is the same thing as log base e of x. If I rewrite this problem, e to the fourth power equals x, e to the fourth power equals x, and I could put e to the fourth power in my calculator, and it turns out to be 54.598 equals x. And that's my solution. Notice, I haven't mentioned this before. Mr. Love, my co-teacher for 5th period, showed this to our students, and I just thought it's kind of nice, because if you do e to the fourth power equals the x, you can see this kind of makes a heart shape, and it makes it maybe a little bit easier for you to remember. So I'll use that when I can to rewrite problems. Okay, this time, for this problem, I have log base 7 of 2 minus x equals log base 7 of 5x. And they are equal to each other, so log base 7 equals log base 7. That's pretty obvious. So if those two things are equal to each other, then we can drop them. And that just leaves me with 2 minus x equals 5x. This is a very nice problem because it's easy to solve. Now I'm going to add x to both sides. 2 equals 6x. Divide by 6, and x is going to equal 2 over 6, which reduces to 1/3. So those are the kind of problems that we look for because they're easy. All right, we have another problem here that we're going to use the rewriting. So I'm going to do 4 to the 6th power equals 3x. So 4 to the 6th power equals 3x. 4 to the 6th power, you have to do this in your calculator, but it turns out to be 4,096. Then I divide both sides by 3, and I get x to be equal to 1,365.3 repeating. You don't have to put that little repeating part if you don't want to, but that's the answer, 1,365.3. All right, for this next example, the logarithm is not by itself, so I have to begin by getting rid of the 7. So to subtract 7 on both sides, notice that that does leave the negative. So now I have negative log base 3 of 8x equals negative 5. I still can't do anything with this because I have to still get rid of the negative. So I'm going to divide both sides by negative 1, so now it makes me have log base 3 of e to the x equals 5. Now we can rewrite it and do 3 to the 5th power equals 8x. So 3 to the 5th power equals 8x. And I have to put 3 to the 5th power in my calculator, which gives me 243 equals 8x. And I divide both sides by 8. And x turns out to be 30.375. Not so bad. All right, hopefully you're getting the hang of this. We have a couple more. For this next problem, again, my log is not by itself, so I have to add 7 first, which gives me 3 ln x equals 11. Then I still have to divide by 3 because the log is not by itself. So ln x equals 11/3. Then you can rewrite ln x as log base e. It's an e, not a 3. Let's erase that and try it again. Log base e of x. Then you can rewrite it. I'm going to try it again. E to the 11/3 power equals x. E to the 11/3 power equals x. And if I put that in my calculator, I get x is 39.12. Okay. All right, now, what do you do in the case when you have two logarithms on the same side? Well, remember that condensing you had to do in the last section? We have to condense this. So first I'm going to condense this. Since it's addition, it's going to become 2x times x. So this is log base 2 of 2x squared. So condensing this problem makes it easier for me to solve. Then I'm going to do 2 to the 5th equals 2x squared. 2 to the 5th equals 2x squared, which then gives me 32 equals 2x squared, because 2 to the 5th was 32. Then I'm going to divide both sides by 2, which is 16. And then I'm going to take the square root to get rid of that, so x is going to be 4. Not too bad. All right, one more example. We're again going to condense. This time we're condensing natural log. This is subtraction, so the 3x will be divided by the 2. So I have ln of 3x over 2 equals 4. I'm going to rewrite it as log base e. 3x over 2 equals 4. E to the 4th power equals 3x over 2. E to the 4th power equals 3x over 2. And let me see if I have more space. Nope, I don't. All right, e to the 4th turns out to be 54 36.598. We actually did that earlier. Now, how do you get rid of a fraction? You multiply by the reciprocal on both sides. So I'm going to multiply both sides by 2/3. So 2/3 times 54.598 equals 36.398. And that's my solution down there. Okay?